Hello, my name is Dr. Koka, and in this video I'm going to show you how to use a rotovap to concentrate a reaction product from a volatile solvent. So this is a rotovap unit, and in the back here you see a chiller. So the purpose of a chiller is to cool down an antifreeze solution and then also send it to the condenser of the rotovap, which is this part here. So there are hoses that run from the chiller to the condenser in the back here, and then there's another outlet from the condenser of the rotovap back to the chiller. So it's in a loop, and is as long as the chiller is on, it is constantly cooling this antifreeze solution. The other part of the rotovap is this end here, where we place a bump guard, which looks like this. This end here, we're going to place a round bottom, and then this other end attaches to the rest of the rotovap. So we can attach the bump guard to the rotovap here, and then if we take a round bottom that contains, let's say, our product from a reaction in a solvent, we can attach it to the bump guard with a cat clip, and then we can use this knob here to lower our round bottom flask with our product into a hot water bath, which is part of the rotovap unit. So we can control the temperature of the water bath here, so we can set whatever temperature we want. There's another component to the rotovap, which is a vacuum pump. So a vacuum pump can be turned on, and it will be attached to a rotovap through a line. So this line here. So when we turn on the vacuum pump, it's going to suck a vacuum out of the rotovap. So it's connected to the rotovap, also through the condenser from a different port from the antifreeze solution that is going through the condenser. Anyways, it creates a vacuum from the top, so it will suck any vapors, anything volatile, from our round bottom up to the top towards the condenser. And then there, when it comes in contact with the co-antifreeze solution, which is running in loops around the condenser, it will condense into a liquid, and then it'll drip down slowly into this bulb here, which is where it ends up. So the purpose of that bulb is to collect any solvent, anything else that's volatile, and then once we have finished evaporating the solvent, we can remove that bulb by undoing this clip here and getting rid of the solvent in either the non-halogenated organic waste or the HO waste. So we have already placed our round bottom inside of our water bath. So at this point, we want to turn on our vacuum pump and also seal our system here. This knob here, we can turn to a couple of different positions, so we can have it so that the hole inside of this is facing out. So that opens the system up to the air, so that defeats the purpose of having a vacuum. But if we turn this in another direction, we essentially seal the system so that when you turn on the vacuum, it keeps the vacuum inside, and we can go as low as our pump allows us. So we're going to do that, and also start to rotate our rotovap. So this is another nice feature of this rotovap. Most rotovap units have this feature. It'll rotate our solution in the water bath, and if we give it enough time, the solvent should evaporate completely and be collected in this bulb. So typically, if you have the water bath hot enough, and if you have a good enough vacuum pump, you should be able to get rid of most solvents within a few minutes, unless you're dealing with something really high buoyant like water or even higher than that. So our solvent here should evaporate around 60 degrees or so. It's acetone, so it should not take very long for but for this video, I'm gonna cut it short. But after you have given it enough time, all the solvent should evaporate and be collected in the bulb. And in the round bottom, you should have your product, whether you have a solid or liquid product. You'll have that now in your round bottom flask all by itself. So you can now move on to characterizing the product. So actually this product here is actually done. So we're going to stop the vacuum pump, turn off, release the vacuum, and stop the spinning, so we can now bring the reaction out of the water. And you can see here that the solution that was formerly a liquid mixture is now a nice solid. So basically we have recovered our product, and our solvent, the acetone, is now collected in this bulb here. So there was probably about 5 to 10 mLs, and you can see that at the bottom of this bulb. And so we can get rid of it now by going to the NHL waste and